Climate refers to the long-term weather patterns of an area. Remember, weather is short-term. This is day to day. Climate usually is an average of about 30 years. Climatology is the specific study of the Earth's climate and the factors that do affect the past, present, and future of climate change. Climate normals refer to the standard values for a location or an average value over a long period of time. The factors affecting different climates include temperature factors, rainfall factors, and the calendar seasons. First, let's talk about the temperature factors. Temperature factors are going to be divided into three parts: topography, ocean currents, and latitude. Let's first look at topography. Topography is going to be referring to the shape, elevation, and features of the surface of the Earth. We did talk about topography a little bit when we covered mountains in first semester. We're going to first focus on some of the parts of topography, including altitude, as well as marine versus continental regions. Altitude is the height of any object above sea level. This is not dealing with actual height. This is dealing with above sea level. Areas of higher elevation are generally cooler. Now, marine versus continental regions generally referred to, is it by the sea or is it inland? These inland locations do affect temperature as well as if it's a coastal region. Land will gain and lose heat much more quickly than water. Water retains temperature, retains the thermal energy. Land areas tend to have warmer summers, and this is important, warmer summers and cooler winters, while the coastal areas near the ocean generally have a cooler summer and a milder winter. This is specifically seen with the Mediterranean. Coastal areas have marine climates with a small yearly temperature range. Generally, so coastal area is going to generally have a very basic or average temperature change. It's not going to be very large in a change. So if we look at the graph here, we can see city A and city B. City A has a large change. If we look at the very bottom, it says the months, starting with D, which is December, January, February, March, and it goes on to October, November, December. So basically, in December, January, and February, it's very cold. In the summer times, it's very hot, so a large change in temperature. While city B does not have a large change in temperature. It may be a little cooler in the winter months, but it's not that much cooler. So it is going to have a lot cooler summer than city A and a warmer winter than city A as well. So city B is most likely going to be our coastal or marine climate, while city A is going to be our inland climate. Ocean currents will move warm and cold water. As we see in the diagram, water is going to be moved to different areas, bringing in warm water from the equator and cold water from the poles. Now, latitude and longitude are two different things. Latitude is dealing with the horizontal lines. A great example of latitude is the equator. Now, longitude, which we will not be focusing on here, longitude is the line that connects the North and South Pole. We're not going to focus on longitude, but we are focusing on latitude, in which these are these horizontal lines, and they will move from the north generally down to the equator, and then from the equator to the south. But they are not going to be touching north and south. They're going to be going horizontal. So the equator is going to be a latitude range of 0 degrees, while the poles are going to have a latitude range of 90 degrees as the latitude marker. Now, latitude impacts average yearly temperature and yearly temperature range. Now, this is sometimes confusing, so please make sure you're focusing on the graphs. if you take a look at the graph at the right, this focuses and compares average yearly temperature with the latitude. So if we start down at the latitude, okay, which is 0, the average yearly temperature is going to be at the equator is going to be very high. So the average yearly temperature is very hot at the equator. But as we move towards 90 degrees, as we move to the North and South Pole, the temperature drops. As you can see, the line is going down. So basically, we're going closer to 90 degrees, but the temperature, average yearly temperature, gets lower on that graph. So if you need help having me explain this, make sure you ask questions in class. So as the latitude increases, the average yearly temperature decreases. So as we get closer to 90 degrees, which are the poles, okay, the latitude is going to increase, going from the equator to the poles. The temperature average in the year will get colder. Now let's talk about the yearly temperature range. There are two graphs that we're looking at. We can see that temperature is going to be more on average at a low latitude. Remember, a low latitude is 0 degrees. That's closer to the equator. But now we see more of a change the higher we go in latitude. So if we move towards 60 degrees, 30 degrees, mid and high latitudes, the temperature changes and fluctuates between the winter and summer months. So the bottom chart focuses on yearly temperature range. We're not talking about an average temperature, we're talking about a range, a change. So let's use both of these graphs. So a change means, is there going to be a difference between the temperature getting hot and cold in the winter compared to the summer months? So at 0 degrees at the equator, there will not be a big change. It's more average. It's usually mainly hot. But as we move closer to the poles, as we increase our latitude, the change increases as well. So there's a big change in the range of temperature between January and July. January is very cold, July is very warm as we get closer to the poles. So if we want to think about North Carolina, New York weather, this is further away from the poles. This is closer, scratch that. This is further away from the equator. This is closer to the poles. So there's going to be a big change between the winter and summer months. Now here's another chart that I want you to be aware of. So the key point is, can you read the charts? So we have average yearly temperature here again, just like the first chart, not the last one that we talked about, but the first one dealt with an average yearly temperature. Now this is not dealing with latitude, this is dealing with altitude, how high we go. And we know if we go high up a mountain, it gets colder. So if we are having a low average yearly temperature, that's going to be a low latitude. High average yearly temperature will be a low latitude. Now as we go up the mountain, we increase latitude. Average yearly temperature gets lower, it gets colder. So at the bottom of the mountain, low latitude, it's a higher temperature. It's warmer at the bottom of the mountain. As we go and increase altitude, it gets colder. So the average yearly temperature goes down. You will have to draw these charts and be aware of how to read them. Okay, here's a topographical map. We actually constructed a topographical map with Play-Doh in first semester, and here is an illustration of the latitude lines. Now here are some latitude lines and latitude zones that you need to be aware of. We know 90 degrees are the poles, North and South Pole. 66.5 degrees north is the Arctic Circle, and 66.5 degrees south is the Antarctic Circle. Both 23.5 north and south are considered or called the Tropic of Cancer, while 0 degrees is the equator. Now, the zone between the North Pole and the Arctic Circle is the polar zone. The polar zone is also between the Antarctic Circle and the South Pole. Then the temperate zones are between the Arctic Circle and Tropic of Cancer and Antarctic Circle and Tropic of Capricorn. And then the tropic zones are between the Tropic of Cancer and the equator and Tropic of Capricorn and the equator. Include and are impacted. Now, the rainfall factors are also impacted by latitude, which are these horizontal lines from the North Pole to the equator. As heating happens, high and low pressure, global winds, and pressure belts impact the wetness and dryness of an area. So 0 degrees, which is the equator, 60 degrees north and 60 degrees south, actually has an area of low pressure. This is also going to be the areas in which we're going to have a lot of rainfall, and it's going to be wet, moist environments. Now, the areas of 30 degrees and 90 degrees, which are the poles, are going to be areas of high pressure, and basically we're going to have low rainfall in these areas. So as water from the oceans rises, as you can see in the picture, rises at the equator, it then moves over and falls. And remember, these low pressure systems will create a higher amount of precipitation. Here we have orographic lifting. As the air rises and condenses, we will have a lot of rain on the prevailing side of the mountain. More grass, it's going to be greener on that windward rainy slope. On the leeward side, it will be drier, as most of the moisture was used up and precipitated on the windward side. So the leeward side usually has less plant growth. Now, the last one we're going to focus on are calendar seasons, and these calendar seasons actually refer to a repeated natural change in temperature, precipitation, and daylight. So for the summer, we have longer days than nights. That means more heating. And this is all impacted by the Earth being tilted on its axis. Now in the winter time, the days are shorter, so that means the Earth cools for longer periods of time. Here we have the summer solstice, which is June 21st. This is when the sun is directly over the Tropic of Cancer in the northern hemisphere. And then we have the winter solstice, which is December 21st. This is the shortest day of the year, shortest day of sunlight. And this is when the sun is directly over the Tropic of Capricorn, which is in the southern hemisphere. So in the winter, the summer, the southern hemisphere is tilted towards the sun, while the northern hemisphere is away from the sun. Now, in the spring and fall, we have what are called equinoxes, and we will talk about those later.